Good afternoon, ladies and gentlemen. My name is Steve McNair. I'm Senior Vice President for Worldwide Non-Destructive Testing. I'm proud to present to you today some new technology of PE X-ray on polyethylene plastic pipe and fittings. Some of the benefits are QC, QA checks and balances, also worked along with computered radiography, digital image plates, and it gives you record keeping for the life of the pipeline. So you can retrieve this information at any given time of the life of the pipeline. I'm going to start off with a short video showing the history of where X-ray has started and where it's evolved to and where it's going in the future.
The first X-ray was discovered accidentally by the German scientist William Röntgen while using high-voltage electricity in vacuum tubes in 1895. In 1898, Marie and Pierre Curie discovered radium, a form of gamma radiation. Instantly, the medical and dental industries found X-ray technology to be of incredible use. In 1922, the American Society of Mechanical Engineers, ASME, permitted the use of X-ray to inspect welded steel parts. In 1929 and throughout World War II, the U.S. Navy used gamma radiation to test all steel welds. WWNDT has the solution that will revolutionize the way our industry tests PE pipe. PE fusion radiography provides digital images of the exterior and interior of any PE pipe or fittings. Essentially, WWNDT has taken the same X-ray technology that doctors and dentists use and made it mobile and durable to withstand environmental conditions. It's also extremely safe for employees, contractors, and customers. The digital image quality with enhancement capabilities ensure that factuality-based records exist for whatever audit comes your way.
So this is showing you a smaller generator that gives a pulse and is able to take a PE X-ray. The benefits of it, it's lightweight, it's easy to get in and out of the trench line, and it's very capable of giving you a highly produced image on film. The ranges are 150 to 370, which Corey will go into a little bit more in detail, but the 150s would be your smaller units versus the 370, which would be a larger unit.
Our units range from 150 kilovolts per pulse to 370 kilovolts per pulse. All units are fixed at 0.3 MA, which is milliamps. It's fixed on the circuit board. This allows us to do all light-duty piping for service to homes, along with heavy-duty plastic, HDPE, heavy wall, and transmission piping.
So a typical computed radiographer system, the CR system combined, allows for quicker processing of the images. Software allows for more tools and measurements to aid in the evaluation of the image. The image and all your images can be stored for the life of the pipeline and can be retrieved at any given point. Any kind of audit situation comes your way, you will be able to retrieve your information. So in this image right here, the system software allows you a full control over the scan parameters. And Corey, how would you describe when you say scan down to 50 micron and 16-bit? What does that mean, and how many shades of gray? Can you explain to us exactly what the 65,536 shades of gray means and how that does help an image quality?
Having full control over the scanner gives you the ability to do anything from small service lines to heavy HDPE transmission lines on the same setup, same truck, and still maintain sensitivity. The higher the bit rate, the higher the quality. So 1 bit is black and white, which allows you 2 colors, as to 16-bit is 65,536 different shades of gray. The more shades of gray that you have available allows you with better definition to any part. So any small discontinuity you'd be able to zone in on, which is especially important in plastic piping. Well, when we get into plastic piping that's going to service, your homes, your businesses, no void, no pocket is too small. So any gas leak is too much of a leak.
Another benefit to the CR is it's environmentally friendly. There is no chemicals in the back of the truck. On the job sites, you don't have to worry about any kind of spills, spill containment. There is no manifested waste from the chemicals. So it's a CR, it's a digital scan. That's the beauty of the CR, the computed radiography system. On this slide, we are looking at a piece of pipe with a valve or a fitting. It's showing a 40-degree slope. And Corey, can you go ahead and give us a little description on what we're looking at and where the 40 degrees plays into and how that gives you a crisper, cleaner image? And please define a little bit more in detail about the backscatter and also the pixel saturation and how that would give us a very good image for the life of the pipe.
Having a more focused radiation beam allows you to really elaborate on the piece that you're shooting without introducing additional backscatter. Additional backscatter is going to negatively impact your image. Your scanner is going to have to compensate for it. There's a lot of variables that will take away from your total image quality, along with the health and safety advisory of your radiation technicians will be picking up less dose throughout the course of the year. The higher the signal, the lower the noise equals a better image. Noise is negative impact from the backside, and signal is true, definite image. Infinite wavelength allows you all the hard and all the soft radiation. It gives you a wide spectrum, which allows a true definite edge for pipe walls, detection on voids, and anything linear that we would find inside of a plastic fitting. More pixel saturation leads on to the infinite wavelength. You're not restricted to a couple wavelengths like you would have with conventional gamma radiation.
So for field applications, it's a very easy setup with multiple use of different tripods, fixtures for attaching to the pipe for your digital image plates, adjustable angles. It's definitely a very friendly situation in a trench. We can take different shots with the trenches. We have different applications, different structures of being able to set the camera up to get the angles for your image. So our next slide is a little video, and it's showing PE fusion in the field with X-ray. Here we have Corey. He's going over at JHA with the field foreman of the placement crew. So they're getting the trench line ready for the tie-in. Here the field foreman is going ahead and discussing parameters of their tie-in with his crew, using the proper restraint systems for the actual coupling, hooking the processor up, scanning the barcode. Now here you see Corey. He's actually doing an ovality check. That's part of our visual inspections when we do the X-ray in the field. Here he's taking a picture. This gives you GPS locations that can be added to all your film digital imaging plates when processing. Setting up for one of the shots gives you that distance for your 40-degree zone. Now he's standing outside the actual zone for radiation. We do 2 shots. We do a 0 and 90 on most fittings. So that took care of the first shot. Now we'll go ahead and do a second shot. Now a typical tie-in like this, you're looking at 15 to 20 minutes for both images to be done and processed. So it's not too bad of a time frame as far as, we're not holding anybody up. Your crew could be working, 15 feet away from us, being that it's basically a 10-foot radiation zone. So here, Corey, you got the second shot completed. Now he'll work his way to the back of the truck and go ahead and start the scan procedures. So in the back of the truck, you'll see that we do have 4K monitors, and the resolution of a 4K monitor, the clarity and the ability to pull out your defects and anomalies as far as what you got going on in the coupling is huge. The clarity is unreal. So this is a real-time scan as far as coming down through. You'll see it on the right-hand side, transfers over to the main window. It's almost there. So with that, you can see how much this system, now you can see there's no voids, no discontinuities. The stab depth is good. All your wires are nice lined up straight as the manufacturer designed them to be. There's no voids or mishaps with the wire as far as blowouts go. Stab depth was very, very good, so job well done to the replacement crew of this. This is where the benefits of PE X-ray overtake the UT for ultrasound. So distribution projects on an average, you look at 60% plastic going in the ground versus 40% steel. With that, steel has all kinds of parameters in place. Your welders are getting tested twice a year. Your more defined people are working that have experience or are going to be doing steel. It is tougher to put in the ground versus plastic, but plastic is a vital part of the natural gas systems all throughout this country. Where do most new hires end up working? They end up working on plastic systems. So where's the checks and balances in place up to this point? There hasn't been a whole lot. Basically, you got a qualification once a year that they do a online course, a test, a PEF, and then a fusion test that's sent in for third-party testing. Other than that, that is it. They are got their blessing to go to the field and actually perform fusion. The PE X-ray that we're about to do and show you, the benefits of that are that we can go ahead and check these new fusers, and if they are performing it to the manufacturer specs and they're performing it to the utmost gas tight joints. So with that, we can give you the inside look. Are they chamfering the pipe? Are they cutting it straight? The stab depth, is it perfect? Is there voids, too much scrape or no scrape, as many you'll see in other slides to come. So with that said, the 60% has less checks and balances in than the 40%. So it's something that the country really needs to look at as far as a whole for the industry. What you're looking at here is a true construction cutout. Now, there's a lot of things going on with this. This actually had inspectors, trained foremen, trained crew. They put this together. Looks like it was a job well done, but there is many things going on with these fusions that you cannot see to the naked eye. As we go through, you'll see there's going to be a few slides that are tied to this example, just to make it sink into what we really got here. So this is a view from the inside. Can you see what's going on with this coupling? This is a biggie. This one really does hamper the system and impacts the system as a whole. Give you a couple seconds to look at it, try to figure it out. So here it is. So the system was designed, it was a bare steel replacement project, and it was originally set up with a one-way feed. The operator of the system engineered it to become a two-way feed. So what the technician failed to do was properly measure his stab depth. What he did here was he overstabbed the pipe and he shut off the one feed going to the one section of the pipe. As you can see with the red circle, he closed it off entirely. Now on the outside of the pipe, was the stab depth marked? Yes. But the stab depth was not measured, because if he measured it prior to the electrofusion going together, he would have caught this and it would have stopped at the measured mark and not go stabbed it all the way to the shutoff point. This is where the PE X-ray comes into play, because now you're getting an inside view of what these technicians in the field are doing, and it's a real true statement. It's not, yeah, did you do the measurement? Yes, see the mark on the pipe. This actually shows you what went into that fitting and how far you actually overstabbed it. He completely closed this off by overstabbing it till it hit the other pipe, taking it from a two-way feed back to a one-way feed. This is where AOCs happen. This is what we want to protect from happening, and this is where the availability to do a PE X-ray comes into play, and this is where it benefits for every operator that's putting a system together. So after we X-rayed, we cut the T's apart. As you can see, there's the actual setup, one T going one way, the other T going the other way. This was the one T that was fully closed off that we just had the red circle around. And as you can see, it is totally blocked off with the opening. Second T, it was halfway blocked off. Also didn't measure that stab depth. This is what can be seen with an X-ray. This is the beauty of the X-ray. We can see what's going on the inside of the fitting. On this second T, it's blocked halfway, but you can take the measurement tools from the CR scanner and apply it to the image. Now you can actually measure the full opening of the actual 2-inch opening versus how far you actually overstabbed the pipe. The same thing is true with voids, miscuts. Everything can be digitally measured. Everything is dealt on the pixel image, and it's all true measurements no matter how big and how much you zoom in and out. Here's an accelerated demonstration of some of the tools commonly used while interpreting a CR image. Measurements of the fusion zone in white, pointers, arrows showing problems and discontinuities, text boxes being able to be added describing findings, the choice of font color to draw your eye to the image. There's a lot of issues going on with T's out in the country here. This one has 3 different pieces going wrong with this T. You have voids that where the pipe ovality may come into play. There was voids up in here that can be digitally measured. You have broken wire where the coil blew out. And with this coil blowing out, this right here is showing the blob of piece of plastic that melted down through with the overheating and the blowout of that coil. But you can see this all with an X-ray. It's a very, very good tool to use. Socket couplings as well. All your fittings, all your fuses, we can check all of them. We can do everything from butt fuse to see if it has a cold fuse, if it's cold rolled. Socket fittings, we can definitely check those. Electrofusion couplings, T's, it all comes into play with an X-ray of PE. So with this one here, what the technician did, one side is stabbed, proper stab depth, it's chamfered pipe. The other side, they chamfered the pipe, but then overshot the pipe, overstabbed it, and it rode up over top of the manufacturer's stops. So when they did that, now he caused a void from the pressure on the top and a void on the bottom from the squeeze of the pressure of the overstab of the pipe. So proper measurement was not used, and when he overstabbed, he caused voids. Now this is a potential leak that's waiting to happen and an AOC that's waiting to happen. This is where the beauty of the X-ray comes into play, and we can stop this before gas is introduced to the system. Here you have a electrofusion coupling. It's overstabbed. The white line shows where the center of the coupling is. The red circle shows where the 2 pipes are actually coming together. You got voids that are happening in this that can be digitally measured as well, plus the total fusion zone. That can all be measured and compared. So this is the stuff that we can actually do for you as far as giving you the image of what's being left in the ground prior to the gas. Not only that, it's a running history. It's showing the information, any kind of information from the CR system can be digitally put on to your image. Your logo, our logo, the contractor, the date, everything can be captured, and that will go for the life of the pipe. That's the best part of this. And even at a small percentage of your replacement systems, if you did this, even a 10% for a replacement system going in a neighborhood, it's going to give everybody a peace of mind. It's going to tighten the fusers up. It's going to do everybody the world of good. So 2 different couplings, same scenario, crooked cuts, short stabs. Again, the manufacturers do not make these couplings with the wire that looks like this. This wire, when it comes from the factory, is nice and straight. Everything's in line. If they start to rough handle this pipe, if they start to not let the actual cool time come down before rough handling, it's going to move the wires. The plastic in the coupling has to re-solidify itself to cool down enough to make sure the rough handling. That is why the manufacturer does a heat time, a cool time, and a rough handling time. That is one of the biggest issues that we are finding with the stuff that we are going out in the field and capturing is the wires are getting moved, voids are being caused, and it's due to rough handling of the pipe prior to letting it cool off all the way from manufacturer spec. As you can see, the gaps can be definitely measured. There is a tolerance for that. So a typical 2-inch, you're looking at no more than a 1/4 inch gap, an 1/8 inch each side. So all of this can be digitally measured, and the judgment can be made to either leave it or to cut it out of the system and start over and do another one. Again, you have voids showing here. You have voids at the top. The black cavities are voids. We just didn't want to mark up every x-ray to the point where it was all red line. So, but there is a lot of stuff going on with these couplings. It's retrievable information. This is the beauty of it. If you're out on a job site and you're on an audit with the Public Service Commission, all this information can be retrieved at your fingertips in a moment's notice. You can access it with an iPhone, an iPad, a laptop computer. It's all there. Any given point. Again, another nice feature with it is GPS locations. So where these fusions are made, you can actually GPS the point with it and actually have that captured on the image as well. And anytime an audit comes your way, you have accurate information on how many were actually shot, where they are actually located, and what you found with that system. So quality checks during construction, it ensures 100% gas-tight fusions are being made. Again, younger guys coming into the workforce always seem to start out on plastic side, and they get thrown into just being able to do fusions. Where steel, it's a little bit more intense. They're getting checked, they're getting x-rayed due to pressures, but the checks and balances definitely need to go to the plastic side as well as the steel and start to mirror what we're doing on the steel side for the plastic distribution lines, and we'll have a much safer, tighter gas system for all the neighborhoods. Some of the disadvantages to not checking it is if you have like that one inline T, you got a block off that was supposed to be a 2-way feed, but now you took it down to a 1-way feed. Now you got a chance for outages. Now you have bad publicity, media coverage, and the cost of construction of digging it up to find out what went wrong. Where if it could have got caught early stage, that's where you save your money in the long run. And it's much cheaper to do a few x-rays on a percentage of a project over an AOC and fighting with all the bad publicity that you'd get from that. So useful as a visual tool. All the operators across this country are part of a DIMP program. It's Distribution Integrity Management Program. The integrity is the biggest part of that. So please, if you see benefits to being able to go ahead and utilize this PE technology, by all means, we're here for you, and any questions you would have, we would be glad to help you out with that and give you some benefits and factors. We can go a little bit more in depth with different fittings if you need. Acquisitions, so different territories. If you are buying a gas product off of another operator in a territory and you are assuming what they had put in the ground prior to you owning it, you can go back and do a checks and balances in place before you spend that hard-earned money on it and you dig a few up at random and shoot them and see what you come up with. It's a pretty cheap insurance policy to make sure that you're buying craftsmanship and not just a system that was thrown together and not knowing what you got. So it does play benefits to that also. So quality control. We've been traveling around this wonderful nation of ours with a highly rated contractor. They've agreed to go ahead and give a testimony to this. The next slide will go into what it's done for their organization. So please, by all means, listen to them, and if there's anything that we can do for you and your organizations, we're here for you, and we'll be glad to answer any questions you might have.
Hello everyone, my name is Larry Crummer. I serve as a Director of Quality for Mears Group. Pipe joining is one of the many important tasks we perform on a daily basis for our customers across the country to help them ensure the reliability of their gas infrastructure systems. The X-ray process also helps us get ahead of the potential defects in materials used in the field. The X-ray supplements our visual inspection of a fusion and allows us to see inside a fitting or other material, potentially notifying us of things like contamination, OVOI issues, or even issues with coils or components within a fitting. Our recently developed partnership with Worldwide Destructive Testing for X-ray and PE pipe is a key component of our quality program and helps provide some important benefits. Practically, because we are X-raying a fusion immediately after it has completed, we are there on site and can address any issues in real time. By using X-ray technology that is at the forefront of the overall industry, we are helping our operation teams to execute at an industry-leading level for our clients. Also, I should mention our unexpected benefit I have experienced as a leader being out in the field with the X-ray team has really helped me personally to better connect the many dots of our pipe joining program. This has been a powerful tool for us to enhance our quality programs further.
So this is the future. This is a welcoming into what is coming our way. We got these images to where it's very, very vital and it's very usable knowledge, and you can definitely use it in your system. Just like with this COVID that's been going around the United States, everybody has gone to virtual meetings, technology. Same thing with X-ray. The plastic side has been antiquated for a while now. We got the technology to bring it up to speed and be able to put checks and balances in place for your systems, for your future systems, and you have record keeping for the life of the pipeline, and definitely have something in case you would get an AOC or in any audit situation. So please, we welcome anything that you might have. Any questions, feel free, and we'll answer everybody as quick as we can here. Feel free to give us a call. So thank you very much. We appreciate the time. Hope everybody enjoyed the presentation, and we look forward to doing some business with you. Thank you very much.